Hey everybody, it's Dr. Jensen with CCJ 3701, Research Methods in Criminology. So this is a kind of a shorter video just to help you with any errors you get in SPSS, especially when you run your regressions. But before I jump into that, I'll make a mention of a few errors you might get when running your bivariates. So occasionally a common error that I see is working file lost. Okay, whenever you get an error like that, it means that usually there was some kind of timeout in SPSS where the file wasn't saved in a timely manner, and it usually happens on apps.ufl.edu where it's been a while since you saved, or for some reason you disconnected from the server. That's when we hate that error, because that means anything you did in the data is now gone and you have to start over. So make sure you save often, save always as you work, so you don't lose any of your work. That's just one of those good practices, especially when you're using the Citrix server, the Citrix receiver. So that's a common error. Another common error that you see has to do with variables getting kicked out of statistics. So you go, I swear I put that variable in there before I ran the statistic, and now it's gone. Where did it go? Well, sometimes there are coding issues in the variable, and a regression or a statistic, maybe using variance or something else, cannot run on it because of those internal issues. And so what SPSS does is it actually removes the variable from the technique. It'll often give you an error, but sometimes it just gets removed, saying, well, I can't regress this, I can't analyze this, so I'm just going to kick it out. And then you're left with kind of this weird output in the end. And so you know something went wrong. You're trying to figure out what it was. So one very easy way to find recoding issues is to take your variable, the variable in question, and run a crosstab with the dependent variable. Actually take a look and see if it can be tabulated across both variables. It'll often reveal that you may have errors. A common error I see is that people forget to do the 1 and 0 categories. Maybe they just do a 1 category and a missing category in the data. You can't analyze that, because that means everyone has the same answer. There are no differences. There is no variance across that variable. And so the variable doesn't vary. Everyone has the same response. And so you can't analyze something where everyone's the same. So oftentimes people make that mistake, and they think a response that's coded as a 0 is the same as missing data. Nothing could be further from the truth. A 0 is still being counted. It's just being counted differently. It's kind of being set aside, but it's still included in the analyses. And so make sure that you don't have any of those kind of things going on. But a crosstab can reveal that to you, to where you can start to see those missing groups that didn't get coded properly. So that's kind of your first line of defense. But let's go a little deeper using this PowerPoint into some other things that happen where we violate the assumptions of a technique, and we can look at syntax and changes and try to figure out what's going on. So when you get strange results in your regressions, usually one of 4 things are happening. Number 1, user error. Number 1, user error. And number 1, user error. Okay, so most of the time it means you recoded a variable incorrectly. You ran the variable in the wrong place. Maybe you switched the independent for the dependent, or vice versa. There's something you did as you ran it that was a problem. So you got to check that first. Number 2, sample issues. Your variable does not have enough cases to analyze. It has a low sample size. There's just too few people. Or your variable has very little variation. 90% of your respondents responded in a similar manner, and so there's just not enough people that had differences, so it's hard to regress. Number 3, collinearity. This is something we haven't talked about, but it's something you might remember from a stats class way back in the day. It has to do with variables that are too similar, variables that overlap and or measure the same concept or a similar thing, so it's not giving SPSS unique observations to regress. So it means we're kind of clumping together and we can't separate out the differences, which again, when you're making predictions and probability, you need to be able to separate one observation from another. So you may need to look at your variables and go, this one's a little too close to that one. Maybe switch that one out and change it to something different. The 4th one is more rare, but it does happen. You have an interaction going on. You have variables that depend on one another to produce a result, and it influences the values that are regressed. And so oftentimes when we study race and social class, we often have an interaction between those two variables because those two concepts definitely influence each other, especially when you look at discrimination and wealth distribution, inequality, things like housing practices or welfare programs. There definitely is a racial element to it when you look at people's access to things or opportunity for things. And so sometimes when those variables are in the same equation at the same time, you get a little interaction effect. Later on, if you go to graduate study, you learn how to test for those and separate out those interactions. But that, again, is something that you'll learn later should you continue. It's not something we're going to worry about right now. But if you do find that that's the last thing going on, you can write a little bit about that later on in your results section if you need to describe what's going on. We wouldn't expect you to be able to do much about it because that's kind of graduate school year 3, year 4 kind of stuff that we work on. Other problems are possible too for linear regression. If you're running a linear regression, OLS regression, it is possible that perhaps a linear relationship does not exist. So try running a scatter plot graph and plot out the residuals, or what we call the standard errors. And so you can do a scatter plot that shows a potential relationship between your independent and dependent. All you would do in SPSS is you just go to graphs, the graphs menu, and then chart builder, and you just select scatter plot. It kind of looks like a shotgun pattern. And you can actually kind of manually drag and drop your variables in there, and it can see if maybe there is some kind of clustering that's going on that looks like a line. It may be that they're all over the place and you just can't get a line to fit it. We can check for that. We also have autocorrelation. We call it autocovariance. Your variable depends on time or a time lag and has correlated values of the process at different times. So the response is going to change over time. So it's values that will actually correlate with past and future. And this is usually seen with the tendency for a response to be repeated, like time 1 and time 2. We have whole different regression equations built to take care of that. So if you were studying recidivism, you're studying divorce, you're studying aging, or maybe premature death or things like that, you actually have to use a regression that we call Cox regression. It also goes by Kaplan-Meier, meaning it's time to event analyses. So we're looking at a time lapse that happens between here and here, because linear regression thinks you're measuring time twice and it comes up with errors. And it just means you're measuring time at 2 different places in time, but you know, SPSS linear regression doesn't really understand that. So you have to try a different technique to deal with that. And that's something you would learn in the second year of a master's degree. You can learn different kinds of regression that deal with those kinds of challenges in your data. Number 3, you may not have normal data. Okay, so we've studied the bell curve and how it has this great symmetry, and we use it to make predictions. You have very skewed data, meaning it's all kind of in one way, or it's shifted more to the right or the left. That can happen as well. So that's something you can kind of see using the graphs tool as well. And these are things you can write about in the discussion section, by the way. If you think these things might be going on, it might be good to disclose them. Binary logistic regression, other problems. Your dependent variable has more than 2 categories. You cannot run a binary, bi meaning 2, binary logistic regression with more than 2 categories. We actually do have what we call multinomial logistic regression or ordinal logistic regression, but you have to order and rank the categories. And again, that's something that sometimes PhD students don't even learn that. It's something that kind of happens at different levels with more study and more practice. And it takes a lot of coordination and sophistication to make sure you're doing it correctly. So that's why I only teach binary logistic, because we can keep track of 2 categories really easy. Having more than that requires all kinds of new techniques and practice to use those. So make sure if you're running binary logistic, you really only have 2 categories, 0, 1. Your sample size is too small. That's probably the most common error I see. Logistic regressions require even more cases to analyze than linear, so you want to have at least 300 cases. It'd be nice to have 3,000 cases because the kind of logarithm or algorithm that's being run on the data to actually complete your logistic regression You need a lot of cases to do that on, to make it go correctly, because it's doing this little matrix inside there, and it needs to have lots of data to do it on. Last one is you have what we call curvilinearity, meaning it keeps changing direction, and we have different kinds of techniques to handle that as well. So those are just some things to consider. Again, I'm not expecting you to test this kind of stuff to be able to address some of it, but it is good to be aware of and kind of know about, especially if you find yourself maybe headed toward graduate study and doing more of this. These are things you'd want to be familiar with. This is probably the most important slide. Again, the user error, the sample issues, because those are things you can do things about, where you may have to make a change to a variable or fix a variable that's broken. So just keep that in mind, and that will save yourself a lot of headaches. So hopefully you found this useful. If you have any of those issues, please send them to me. Take screenshots. We can work through them together. I don't want you to feel alone in doing this. So other than that, we'll see you in the next video.